Hey class, and welcome to Chapter 4. Chapter 4 is going to be about the market forces of supply and demand. And what I'm going to do is I'm going to divide this into 3 videos. So what we're trying to do here is we're trying to make these so that we can look at the forces of demand first, which of course is the consumer portion, the forces of supply, and then we'll look at the equilibrium. So there are 3 videos for this particular chapter. So we're going to start off with a market, because obviously if we're talking about market supply and market demand, we need to define what a market is. And a market is a group of buyers or sellers of a particular product. Okay, so far so good. So buyers as a group determine the demand for the product. Sellers as a group determine the supply of the product. Markets take all sorts of forms. You can have very highly organized markets, like a lot of agricultural commodities. The American Dairy Association, Organic Valley is actually a cooperative of many, many different dairy producers. It's highly organized. And then you can have very low or less organized things, like the market for ice cream in a particular town, where you may have 2 or 3 different independents all working very separately from each other. There are different kinds of market structures. One of the market structures is a competitive market. And this is a market where there are many buyers and sellers. Pretty much most of the United States economy runs on a competitive market. And each has kind of a negligible impact on the market price by itself. Now, this is not always true in the United States, is it? Because there are markets in which there are only 4 or 5 firms that control the pricing, i.e. the telecom market, right? And that would be more of an oligopoly. But in a competitive market, every buyer doesn't really have enough market share that they can help with the market price. And in turn, the prices are determined by all the buyers and all the sellers. So everybody has to interact together. So you have a bunch of sellers that each don't have enough market power to kind of rule. So we don't have any big player. And at the same point in time, you have all of us, and we're all buying separately. Perfectly competitive market is when all goods are exactly the same. There are buyers and sellers are so numerous that no one has any effect on the market price. And this is, they're all price takers. The market price becomes what all the buyers are willing to buy at and all the sellers are willing to sell. We're going to assume perfectly competitive. So this is kind of a boring little market, if you think about it. That means that there is only one kind of mechanical pencil in the United States. It is, I'm holding a Bic pencil, and it's a mechanical pencil, and mine is orange, and it has a blue tab on it. That means that the only pencil that you can buy that's mechanical is this one. Kind of boring. But it does allow for an economic model that we can analyze. And remember how we were talking about the fact that sometimes economists make things simple so that we can analyze what happens. There are obviously other kinds of market structures. A monopoly. Yes, just like the game, a monopoly has only one seller. And what's the principle of the game? To gain as much property as possible in this particular game, right? So it's all about property. That's a property monopoly, but there are many kinds of monopolies, and the monopoly sets the market price. And then there are a lot of different ones in between. And most of the world falls between perfectly competitive, in which we only have one pencil, and a monopoly where there's only one seller. And that is something that you would study quite a bit in micro, but for this, we're going to assume the perfectly competitive. Demand. That's what I promised I would discuss. Demand. The quantity demanded is the amount of a good that its buyers are willing and able to purchase. Sounds pretty good. The quantity demanded. How much they're willing to demand. The law of demand says, other things being equal, we'll get back to that in a second. When the price of a good rises, the quantity of demand of a good falls. Think about it logically and kind of as a consumer, right? If the price of something goes up, are you going to buy more of it or less of it? Probably less of it, just because, you only have so much money. When the price falls, the quantity demanded rises. Partially, this is due to the fact that people who were not able to buy it at a higher price can now buy it. And also, it means that we are more apt to buy it than we were before. We're going to use chocolate bars a lot in this particular class, so get used to the chocolate bars. So, in an example of chocolate bars, if we suppose that the price of chocolate bars is 80 cents, and at this price, you're likely to buy about 4 bars or more. That means that if the price of the chocolate bars was $1.20, you say to yourself, well, I'm not going to buy 4 or more, I'm going to only buy 3. And if the price went to 2, you're likely to buy even fewer. This particular chart below, right here, is showing the law of demand. It's saying at 80, you buy 4. At $1.20, you buy 3. At $2, you buy 1. This is your demand chart. It's saying at each price, what quantity are you willing to buy? And as you can see, as the price is going up, right? It went from 80 to 120 to, ta-da, $2. What happened to the demand? Yeah, it went down because as the price gets larger, we demand less. So, if you were to look at the entire economy as a whole for a particular snack shop, let's say, and you were to take all the customers who walk into the snack shop and interview each one of them or look at their demand across each one of the prices that we just looked at, you would start to see that as the price went up from the low of 40 to the high of 500, what happened to the quantity demanded? The quantity demanded went up as the price goes down. So as the price went down, when it started at 2 and went to 160 and then went to 120 and then went to 80 and then went to 40, the demand went from what? It went from 100 to 200 to 300 to 400 to 500. So what's happening is that more and more candy bars. So showing the law of demand. As the price goes down, the quantity goes up. As the price goes up, the quantity goes down. It's an inverse relationship. This is what we call a demand schedule. It's telling us at every price how many people are willing to buy my product at that particular price. And why do we care? Well, because how do we determine our price if we don't know what our customers are going to be willing to pay? Yes, it's a good question. If you actually consider the markets in the United States, you will see that these types of demand schedules, although not necessarily quite so linear, occur all over the place. Manufacturers, and in this case, people selling, are looking at prices and price sensitivity for all the consumers to see what price is kind of their sweet spot. So remember we were looking at that chart before? Well, we took that nice little, table, and we now plot it. And why are we plotting it? Because we have to figure out what it really looks like on a graph. So we knew all the different data points, right? So we knew at $1.20 that the demand was going to be 300. And we knew at 60, the demand was going to be 160. And we knew at $2, At $2, the demand was going to be 100. Each one of these points then becomes a point on our demand curve, and we are now able to what? Plot a demand curve. The demand curve has an inverse relationship, as you can see. As the price goes up, the quantity goes down. As the price goes down, the quantity goes up, and this becomes the demand curve for chocolate bars. So you have a demand chart and you have a demand curve. The demand schedule is what we just looked at, right? And the demand schedule is basically the demand chart schedule. It's a table that shows the relationship between the price of the good and the quantity demanded. So in this particular example, we've got Helen, and she has a demand for lattes. So depending on the price, Helen's going to demand a different quantity of lattes. So for Helen, if the price is 0, she's going to buy 16 lattes. If the price is $1, she's going to buy 14 lattes. If the price is $2, she's going to buy 12 lattes. If the price is $3, she's going to buy 10 lattes. If the price is $4, she's going to buy 8. And if the price is $5, she's going to buy 6. And if the price is $6, she's going to buy 4. As the price went up, her quantity demanded went down. Boom, 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 boom. Correct? So you'll notice that Helen obeys the laws of demand. When the price of a good rises, the quantity demanded of the good falls. Helen makes sense, partially because of why. Helen only has so much money. She can't necessarily buy lattes if she doesn't have the money to pay for them. Then taking Helen's example, just as we looked at the chocolate bars, you can see that you can basically chart this. So at 0, Helen bought 16. So the price is 0, she bought 16 right here, correct? When the price is $1, she bought 14. So when the price is $1, she buys 14. When the price is $2, she buys 12. $2, 12. When the price is $3, she bought 10. $3, 10. When the price is $4, she bought 8. $4, 8. When the price is $5, she bought 6. And when the price is $6, she bought 4. So if you were to be creating this demand curve from the demand schedule, you would be plotting each one of these little points, just like we just did now. And then, once you got all the little points, you would then connect it with a line. Now, this is a linear line. And remember how I said that models in economics are frequently simplistic. Well, in this particular case, yes, it is simplistic, because would this be true in real life? Probably Helen's model or Helen's curve might have more of a bow, but in this particular case, we're going to assume she has a nice linear relationship. Now, we looked at the demand schedule for Helen. That is an individual's demand schedule. Now, how do we translate that individual's demand schedule to a market? Because we're really talking about markets, correct? And we defined a market before. So there is Helen's. In a market demand schedule, you take all the individual people, so Helen and Ken, if there's only 2 people in a market, but there could be Helen and Ken and Mike and Stu and Jim and blah, 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 blah. And you basically look at every price point, and then you add up their individual demands to create the market demand. So in this case, 16, which was what Helen would buy at 0, and Ken's 8, which is what he would buy at 0, now becomes 24. 16 plus 8 equals 24. Do the same thing for at $1. 14 plus 7, 21. $2, 12 plus 6 equals 18. $3, 10 plus 5 equals 15. $4, 8 plus 4 equals 12. $5, 6 plus 3 equals 9. $6, 4 plus 2 equals 6. And you can actually envision, using market research, how companies would do this. They would go out and they would ask people how many they would buy in a month or a week or whatever the time period would be at different price points. Then they would combine the data across multiple people and come up with the demand schedule in that particular market at different price points. This is where market research, obviously, and consumer research becomes very, very closely intermingled. Now we have the market demand. In this particular market, there's only 2 people, but we now know what the market demand is. By knowing the market demand, we can do the following. We can now create a market demand curve. So whereas before we had Helen's demand curve, and it was nice, right? We now would plot each one of the points just like we did before. So we would start off and we would say at 0, the market. And remember, in that market, they didn't perform exactly the same, did they? They were not behaving exactly the same. We can plot out each point. We can say, okay, at $1, it was 24. At $0, it was 24. At $1, it was 20. At $2, it was 18. At $3, it was 15. At $4, it was 12. At $5, it was 9. And at $6, it was 6. Then once you have all those points, you then can create the curve. Nice straight curve. Chances are in real life, it might be more like something weird, right? Because people don't always behave logically. But remember, we had that assumption, people behave logically. Now, thinking back to the first wave we were on, remember how we were looking at Helen and Ken? Now, they didn't behave exactly the same, did they? No. And I just want to bring back that one point here. Helen wanted 16 at the price of 0, but Ken only wanted what? 8. Now, he only dropped his demand 1 for every price point, where Helen dropped hers by 2 for every price point. They literally have a different caffeine intake habit. And I just wanted to mention that because consumers are not going to behave logically exactly the same. So the demand curve shows how price affects quantity demanded, all other things being equal. Remember I said we would get back to that? Yeah, here we go. So this all other things being equal is really very important. What are these other things? They're called non-price determinants. Why? Because price moves you along the curve. Remember, we just looked at that. Helen's and Ken's individual demand added up to the market demand, and the market demand was identified by price. There are non-price things that actually shift the curve. And why do they shift the curve? They shift the curve because there are things that affect everyone's demand but don't affect it equally, or may affect it equally. In this particular case, they are things like the number of buyers. So in our market, we only had Helen and Ken, correct? Well, what if we had Helen, Ken, and Susie? Susie answers the market. Now, granted, this market is 2 people, now becomes 3. Chances are it would be a little bit bigger than just a person, but we're just going to go with that. If Susie answers the market, now all of a sudden the demand is going to change, isn't it? Because now we're going to have to add Susie's curve to Helen and Ken's, which means the overall market demand is going to shift. Probably outward, more people, bigger, less people, smaller. Income. What if Ken all of a sudden started making more money? Well, he may be willing to buy more lattes if he starts making more money. If a bunch of Kens start making more money, that could affect an overall market. Prices of relative goods. What if the price of what Ken is buying instead of lattes, for instance, let's say he's buying Red Bulls because he needs his caffeine. So Ken buys Red Bulls and Red Bull drinks, all of a sudden the price goes up astronomically. Ken may decide to switch away from Red Bulls and switch to lattes. Tastes and preferences. What's in today and out tomorrow? Pumpkin spice lattes, right? Tastes and preferences and expectations. What do we think is going to happen in the future? The notion of stockpiling comes into the account here. But as people think that something's going to change in the future, it may change their behavior today. These 1, 2, 3, 4, 5 things are called non-price determinants of demand. They're things that determine buyers' demand for the good that is other than the good's price. And each one of these can shift the demand curve. An increase in demand, any change that increases the quantity demanded at every price, will shift the demand curve to the right. A decrease in demand, any change that decreases the quantity demanded at every price, will shift the demand curve to the left. You were like, what am I talking about? So, in this particular case, anything that shifts or increases the overall demand for the goods will shift the demand curve to the right. This is a rightward shift, an increase in demand curve. Anything that decreases the demand will shift the demand curve to the left. So back to our examples. If we added more buyers to the market, we would shift the demand curve where? This way. If buyers left the market, like for instance, after a hurricane in like Louisiana, there was less people buying, the demand curve shift inward for the Louisiana market. So back to chocolate bars. Let's take a look here. So if there was an increase in the number of buyers, we just talked about that. So if there was a large candy lovers convention that came to town and people wanted to buy more chocolate bars, the demand curve would shift to the right because there would be increased demand at any price point. Now, remember we're making this simplistic, but that means that if we were back to this $1.20 price, before the quantity demanded was 300. The new quantity demanded, if the demand curve shifted over, was 400. This is the new quantity demanded. So the quantity demanded is relative to the price. The demand curve shifting is relative to the shift factors, non-price determinants. Income. Now we get into normal and non-normal goods. No, normal and non-normal goods have nothing to do with anything to do with marketing. It has everything to do with our behavior. The demand for a normal good is positively related to your income. What does this mean? This means that your income is a direct association with a normal good. So an increase in income causes an increase in demand at each price. Okay, so for instance, a normal good could be lattes. However, an inferior good is negatively related to income. That means so as your income increases, it actually shifts the demand curve to the left because you buy less of it. So what are examples of this? And this is really one of the things that is directly associated with social norms. So for instance, people may think that riding the bus is an inferior good. Driving your car is what they aspire to. In that case, if that is the social custom, then as people's income rise, less people will take the bus and more people will drive a car or buy a car. That becomes an inferior good for that particular market. Hamburger. A lot of times people would prefer to buy steak, etc., and they would feel that hamburger is an inferior good. It is a little bit about perception in this case. So, the example of chocolate bars. During a recession, people are likely to have smaller incomes and can't buy as many goods. And that would include chocolate bars at any price. So what happens in that particular case is the demand for chocolate bars would shift to the left because people would buy less of them. People's income are less. It's a shift factor. It shifts the demand curve to the left. That makes chocolate bars a normal good. And that means that if there was an increase in income, it would likely shift to the right. Normal goods shift that way. Two goods that are substitutes, if a price increases on one of them, may cause an increase in the demand for the other. Huh? Well, what that means is if there's an increase in the price of something that you consider, like when you're standing in there in the store, oh, I could buy this, or I could buy this, I could buy this, or I could buy this. Two different options. For instance, pizza and hamburgers. If there's an increase in the price of pizza, that means that you consider and you think to yourself, okay, well, I can have pizza or hamburgers. That means that you decide to gravitate away from pizza to hamburgers. So it means that in the end, there's an increase in demand for hamburgers. So because pizza increased its price, there's a shift in the hamburger demand curve. They are called substitutes. Coke and Pepsi. You may disagree with that one. Laptops and desktop computers. Some people may disagree, but the CDs and music downloads. Although these days, I don't know how many people buy a CD, but once upon a time, those probably were substitutes. Here's an example back to our chocolate. All right, for instance, imagine that the licorice prices fall in half while chocolate bar prices remain exactly the same. You know, if you're kind of just in it for the sugar rush and you're not in it necessarily for the chocolate taste, you very well may switch to eating licorice. Because you're standing in the candy aisle and you look at your chocolate bar price and you look at what a deal you can get. You can get much more licorice for the same price. People are going to switch. So what ends up happening for the chocolate bar is as people substitute licorice for chocolate, because licorice is cheaper, it also changes it. So it changes the demand for chocolate at the same time because licorice is considered to be a substitute. So the demand for chocolate goes down and people start buying licorice. Complements. Haha, yes, very different. Complements are two goods that actually move together. So if there's an increased price in one, it's going to cause the demand in the other to fall. So if there's an increase in the price of computers, the demand for software will go down. Why? Because if people buy less computers, they don't need as much software. They complement each other. College tuition and textbooks. If college tuition goes up, maybe there's less people that go to college. If less people go to college, why do they need to buy textbooks? Bagels and cream cheese. If you, and majority of the population in the area eats bagels with cream cheese, if the price of bagels goes up, there's less demand for cream cheese. Eggs and bacon. Chocolate bars. S'mores. Yeah, that's their complement, right? So, complementary good is used with another good. What is the one thing that chocolate bars are used with? Graham crackers and marshmallows. The favorite of the world, s'mores. So, you have double the complements, don't you? So, you and lots of other people, right, buy fewer boxes of graham crackers and bags of marshmallows if indeed the price of candy bars goes up. So the demand curve, what happens is the demand curve for candy bars actually goes down. I'm sorry, I said that wrong. If the price of graham crackers and marshmallows goes up, so you walk into the store, you're gonna buy your s'mores, and you say to yourself, okay, gotta get my graham crackers, gotta get my marshmallows. Oh wait, those marshmallows are twice as expensive as they were before, and those graham crackers are. Do I need to make s'mores? Maybe I'll make cupcakes. So then you don't buy the chocolate bars. So what happens is the demand for chocolate bars is basically affected by the price of the complementary goods, graham crackers and marshmallows. Tastes. Anything that causes a shift in taste towards a good will increase the demand for that good and shift it to the right, right? Because if people are thinking they should buy more of something because people's tastes are moving in that direction. Example of this is the Atkins diet. And in the 90s, it was really, really popular. One of the proponents of the Atkins diet was eggs, because eggs was considered by Atkins to be a perfect source of protein. So it increased the demand for eggs. It was fashionable to eat eggs. So the entire demand curve shifted to the right due to taste and preferences. In the case of our chocolate bars, you can see some different effects. People who buy more chocolate bar, oh, interesting. I just noticed that this slide is interesting. Okay, so if scientists were to discover some new health benefits from eating chocolate, you can bet that people would buy more chocolate bars. That means the demand curve would shift out here, correct? So, but if you look at this newspaper article that's in this example, it says eating chocolate is bad for your health. Well, if everybody read that, what would happen to the demand curve for chocolate? It would go in, correct? So if eating chocolate was good, it would go out. And if eating chocolate was bad, it would go in. Expectations. If people expect their income to rise, the economy is churning along, things are great, people expect that they're going to make more money next year than they made this year, their demand for things that are expensive may increase right now because they expect that their future will be great. If the economy sours and people are worried about their future job security, the demand for things like new automobiles or housing might decrease because people are worried about the future. If there's a fear of a chocolate shortage, I know, that would be awful, wouldn't it? And there's rising prices in the future because there's a chocolate shortage. Chocolate lovers may buy a chocolate bar right now to avoid the future prices, the stock-up effect. This would increase every single demand point. Now, what does this mean? This means that whereas before, at $1.20, the demand was, typically 300. All of a sudden at $1.20, the demand becomes 400. So at every single price point, there's more demand than there was before. And I'm guessing they have to put it in the freezer or something. So to summarize, price causes a movement along the demand curve. So as you change the price of your particular thing, like chocolate bars, people just move between points. Remember, the demand curve is a representation of all those points. So as the price changes, people just move along the curve. If the number of buyers changes, if they become higher, what happens? The demand curve shifts out. If there's less buyers, the demand curve shifts in. If income increases, the demand curve shifts out. If income decreases, the demand curve shifts in. Case of recessions. If the price of a relative good, okay, now remember, we got to think about complements and substitutes. Substitutes are going to affect things differently, right? Because if the substitute's price goes down, then people are going to buy more of the substitute and less of yours. So your demand curve is going to go down. If the price of the substitute goes up, then maybe the demand for your product is going to go. Now, what if it's complements, like our s'mores? The price of the complement goes up, your demand may go down. If the price of the complement goes down, your demand may go up. And then there's tastes and preferences. Tastes have all to do with what people's expectations are in terms of tastes. And this is a lot to do with marketing, right? So for instance, the Atkins diet and eggs, there are many different taste ones we can come up with. And then expectations. If you're listening to the economic report and it looks like it's going to get worse in the future, what are you going to probably do? Probably not spend so much now, which means that if everybody's acting that same way, you can easily get the demand curve to shift inward. So we're going to play around with this a little bit. On your chart, this is the demand for music downloads. And then there's the price for music downloads. So what we have is the demand for music downloads. The demand is always shown as follows. Quantity is on the bottom, right there. and price is always here. So here's your price, and here's your quantity. So we're going to look at three scenarios. The price of iPods fall. At this particular case, we're assuming that we're downloading onto this little iPod. The price of music downloads falls, or the price of CDs, which we are going to consider to be a substitute. The first case, if the price of iPods fall, that would mean that you could download and you would have a place to put it. So if you consider this, for music downloads, iPods are a complement. Just as for music downloads, memory space on a phone is a complement, right? Of course, I have a little caveat in here, assuming that you need the iPod to download the music. These are complements. If it's a complement and the price falls of one, it means that all of a sudden there are more people out there that can buy this good. If there are more people out here that can buy this good, it means that the demand curve is going to shift to the right. This is a classic example of what? A shift factor. In this case, the shift factor is what? The shift factor is the price of a complementary good. Prices. Second one, the price of music downloads falls. This is a trick question, actually. Pricing on your own demand curve, increasing and decreasing, does what? Moves you along the curve. So all that's really happened here is the price went from P1 to P2. So we went from this point to the P2 price, and the new quantity now becomes Q2. The third example is the price of CDs falls. Assuming that they're substitutes, if the price of CD falls, people are going to substitute away from music downloads to CDs, if indeed they consider them to be substitutes. You could look at this in terms of two different streaming systems, Hulu and Apple TV or something. If one goes down, people are going to substitute away from it. In that case, the demand curve shifts inward or to the left. So demand curves are used to look at lots of different things. And one of the things that it's definitely used to look at in the United States is what is the best way to reduce the quantity demanded for cigarettes? And this is a public policy debate, but it kind of makes you think about supply and demands. There's two different ways. You can shift the demand curve for cigarettes and other tobacco products, or you can raise the price of cigarettes. So how are you going to get people to stop smoking? How would you shift the demand curve? Well, you can shift the demand curve in a lot of ways. One of the ways you can shift the demand curve is by preferences, right? Public service announcements, mandatory health warnings. Now, information stopping can affect preferences, but it can also affect people's ability to basically even want the product, kind of decreasing the demand. The prohibition of cigarette advertising on TV is, what is it doing? It's reducing the people awareness. If successful, this would shift the demand curve to the left. So a policy that discourages smoking will shift the demand curve to the left. So what ends up happening in this case? It means that the price hasn't changed. So let's say the price is $2. It just means that now all of a sudden the demand at $2 went from 20 to 10. The second way is to raise the price. Well, how do you raise a price? You tax the manufacturers. So if you tax the manufacturers, they have to pass that price along. So if you were to increase the price by 10%, statistics show that what this does is it will decrease smoking by about 4%. good old research. If you increase the price by 10%, teenagers will actually reduce their pricing by 12%. Interesting. So obviously what we're saying is teenagers are much more price sensitive. Now, anybody who read ahead has just seen what I just said. However, what ended up happening is they found out an interesting thing. They found out that cigarettes complement was marijuana. So whereas they decreased the overall demand for cigarettes, people just moved over to marijuana. So what ended up happening? The first one was the discouraging policy, which moved the actual physical demand curve. So what did it do? It said, okay, now what we're going to do is the demand used to be 20 at $2, and we're going to make it by discouraging people 10. The other policy was literally moving along the demand curve. So it took the price from $2 and made manufacturers make it $4. And assuming that in the case, we went from 20 to 12. What if you did them together? I know. And that's exactly what ended up happening in the United States. We did both. The next set of videos that I'm going to be presenting are going to be about supply. I'm going to stop the video now so that if you need to catch up on your notes, you can. And then cue up the next video and we'll start talking about the forces of supply and demand, the supply side.